Hi, my name is Catherine. Today we're going to be going over a limiting reactant or limiting reagent problem. So let's go ahead and start off by reading it out. For the following reaction, we have 21.8 grams of iron being allowed to react with 5.10 grams of oxygen gas. So let's start. We have our iron solid is one of the reactants in the equation. We also have our oxygen gas. We're going to unite those with an addition symbol. And then we have our product, which is going to be given by the arrow, and that our product is FeO, or iron 2 oxide. Now the only thing we have left to do is to balance it. So because we have two oxygens right here, that means we're also going to have two oxygen atoms on the right side. And because we now have two iron atoms on the product side, we're going to have two iron atoms on the reactant side. So that is our balanced reaction. And the reason that we're writing this balanced equation down is so that we can see the mole ratios that vary between each of the different compounds. So now it's asking, what is the maximum mass of iron 2 oxide that can be formed? So that's how much of the product can we make with these two reactants and with the amounts that we have of each of them. One of them is going to be a limiting reactant, and one of them is going to be an excess. So one of them, we're going to use all of it up, and the other one, we're going to have a little bit left over. And so we're just going to calculate which one is which. So we're trying to figure out first, is iron the limiting reactant, or is oxygen gas the limiting reactant? So let's see how much product we can make from the 21.8 grams of iron that we're starting off with. So starting off with 21.8 grams of iron, we know from our periodic table that iron has a molar mass of 55.845. So that's the molar mass right there. And we know that the molar mass is how many grams per 1 mole of iron. Now, using our formula, or our balanced reaction, we know that 2 moles of iron will give us 2 moles of iron 2 oxide. So that ratio is 2 moles of iron to 2 moles of iron 2 oxide. Now, we're trying to figure out how many grams of iron 2 oxide can be produced. So we know that 1 mole of iron 2 oxide is 71.85 grams, because we just add 1 atom of iron to 1 atom of oxygen. That's 55.85 plus 16, which gives us this number. And now, if you multiply every single number on the top and divide by the numbers on the bottom, we're going to get 28 grams of iron 2 oxide that can be made from this iron. Now, let's see how much product can be made from 5.10 grams of oxygen gas. So going through the same process, we are able to, the only difference is that we're starting with 5.10 grams of oxygen, using the molar mass of oxygen gas to convert to moles. Now we're in moles, and we know that 1 mole of oxygen gas will give us 2 moles of iron oxide. And then we know already from here that 1 mole of iron oxide, or iron 2 oxide, is 71.85 grams of iron 2 oxide. And that's going to give us 22.9 grams of iron 2 oxide. Now, whichever value is the lowest, that is going to be which reactant is our limiting reagent. So out of these two, we can see that the 22.9 grams is the lowest value. So that means that that's going to be our limiting reagent. So oxygen is going to be limiting, and we're going to have this iron in excess. So I'm going to put L here for limiting, and iron is going to be in excess. Okay, so now let's go on to the next part, which says, what is the formula for limiting reagent? We already know it's oxygen gas. It's right there. And what mass of the excess reagent remains after the reaction is complete? So we just take our limiting reagent, which was the 5.10 grams of oxygen, convert it to moles, and then use the mole ratio from the equation and convert to iron. Now we see how much iron was actually used in the reaction. And then if you want to know how much it remains, you use what you started, subtract what you used, and you get how much iron is in excess, which was 4 grams. Okay, let me know if you have any questions.